Now we are going to see about the introduction to electrical power system and AC supply. In the day-to-day life, we use electrical power for various applications including the domestic and industrial and agricultural purposes. For most of the domestic applications, we are using a single phase AC supply with a voltage of 230 volt. And if we are using the 3-phase supply voltage, the 415 volt. For high power industrial application, the 3-phase AC supply is used. Depend upon that requirement. If 6.6 kV or 11 kV or 430 or 415 volt. For certain domestic applications such as telephones, etc., the electronics items, these are used by the DC supply. For certain applications such as electric trains, as a high voltage DC system is used. The difference between the AC and DC quantities. We are using both AC and DC supply system. What are the difference between AC and DC quantities? About the waveform, it shows the sinusoidal waveform. About DC, it is unidirectional, the constant magnitude, it shows in the DC side. It is the signal in that AC waveform, it is a signal which changes its magnitude, both positive and negative polarity. But in the case of DC, it is a signal which changes its magnitude but does not changes its polarity. Magnitude may be changed, but its polarity does not change. That is called as DC. About the use of transformer, only AC supply is possible to use the transformer to step up or step down the voltage. But in the case, not possible to use transformer in DC supply. About the distribution efficiency in AC is high compared than the DC, because DC supply is having the low efficiency. The design of machines is easy in that AC supply system. The AC machines are easily designed, but not easy in DC, because it is having the commutator and etc. That is components are excess in that DC machines. And also carbon brushes, these are all the excess parts in DC. About the generation is easy in the AC supply system, but DC supply system from the AC waveform using commutator or rectifier to convert the naturally we have received AC supply, it have to convert to DC through the commutator or rectifier. About the applications of AC system, the AC motor, domestic and industrial supply, etc. The DC applications are DC machines, HVDC systems, etc. The electric power supply system can be subdivided into 3 subsystems as follows. First one is generation system, the generating power plants, both conventional and non-conventional power plants, and the transmission system, distribution system. These are all the power supply system. The electrical energy generated by the generating system is transmitted to the load center by the transmission system. This energy is then distributed to the distribution system. The distribution system give the supply to various loads, the consumers, the domestic, industrial, agriculture, these are all the various consumers. About the generating system, the function of generating system is to generate electrical energy. The input to such a system may be thermal energy, hydro energy or nuclear energy or any other form of energy. It is converted into electrical energy. These are all the conventional energy sources. The generating system are broadly classified into two types: conventional system and non-conventional system. By using the conventional source, they generate the electrical energy is called conventional energy system. The non-conventional energy system are through the renewable energy system. They convert the electrical energy, that is generate the electrical energy, is called the non-conventional energy systems. The conventional system generating system are those which take non-renewable energy sources of energy as a raw material. The conventional system are classified as follows: thermal system or hydroelectric system. In the thermal system, converting heat energy of fuels like coal, petrol, etc. into electrical energy, that is called a thermal system. The thermal system uses the conventional energy sources like coal, diesel, gas, etc. These are all the conventional energy sources, some of the conventional energy sources. In the hydroelectric system, converting the potential energy of stored water into electrical energy. All the power plants are having the sources to convert mechanical energy. That mechanical energy given to that alternator or generator, it converted into the electrical energy. The form of obtained energy is different, but the obtained energy, the outcome of that energy is electrical energy. The nuclear system converting heat obtained by the nuclear fission reaction into electrical energy. In the diesel electric system, converting energy stored in diesel into electrical energy. About the non-conventional system, non-conventional systems or renewable energy systems are those which use the renewable energy sources for producing the electrical energy. The non-conventional systems are classified as follows: solar energy, wind energy, tidal energy, energy from biogas, biomass, ocean thermal energy conversion, tidal. These are all some examples for non-conventional energy sources. About the extra high voltage transmission system, EHVAC. The increased demand of electricity needs more generation of electrical power as the generation takes place at remote places. An efficient distribution system is necessary to distribute that electrical power. The figure 1 shows the simplified single line diagram of electrical power transmission and distribution system. Initially, the generated voltage is 11 kV. This 11 kV converted, that is stepped up into 132 kV. That is a primary distribute the power from, that is a power generating station to some distance. That is called the primary distribution. Then next, the receiving station receives the 132 kV It again converted into 33 kV, stepped down. It is called the secondary transmission system. This secondary transmission system obtained voltage 33 kV, again converted into 11 kV for power distribution. In the step of transmission, it having the two step. One is primary transmission, the 11 to 132 kV. Again secondary transmission, 132 to 33 kV. That 33 kV receives in the substation. That substation stepped down into 11 kV for primary distribution. For the secondary distribution, that 11 kV converted into stepped down to 400 volt. It provided to the various consumers. This is the single line diagram of electrical power transmission and distribution system. In the distribution, it is having the two stages, primary distribution and secondary distribution. If the bulk consumers receives the 11 kV, that is the industrial consumers receives 11 kV from the primary distribution. The domestic consumers receive the 400 volt in the secondary distribution. About the transmission system, already we told about primary transmission system and the secondary transmission system. The primary transmission systems may be using 3-phase alternators at 6.6 or 11 or 30.2. It is the generator voltage, or 32 kV. This is then stepped up by the suitable 3-phase transformer to 132 kV. The generated voltage stepped up into 132 kV. This voltage is stepped down to 33 kV using step down transformer, which is at receiving station. In the generating station, stepped up into 132 kV. In the receiving station, again stepped down to 33 kV by using the step down transformer. About the distribution system, is further divided into primary distribution system, secondary distribution system. The output of the substation at 33 to 11 kV can be directly given to the customer whose demand exceeds 50 kVA using special feeders. This is the primary distribution system. It is the industrial consumers. About the secondary distribution system, the secondary distribution is done at 440 or 400 or 230 volt. For single phase supply system, it supplies the 230 volt. A reduction in voltage level from 11 kV to 400 or 230 volt is done by the step down transformer at the secondary distribution substations. Thank you.